In this titration, we're going to use our standard solution of potassium, hydrogen, phthalate to determine the concentration of a solution of sodium hydroxide. In this setup, the sodium hydroxide is in the burette because we're using a phenolphthalein indicator which turns pink in alkaline solutions. This is our rangefinder titration that we've already carried out. The first thing to do then is to pipette 25 centimeters cubed of potassium hydrogen phthalate, the acid in this titration, into the conical flask. So to do so, we can use the pipette filler we've got here, draw up the solution, and one thing we can do with a pipette filler such as this, if we need to, is just remove it. We don't have to worry about the solution running out really quickly, and then just replace it onto the end and continue to draw up. Now, the facility to do that, of course, also means that you can use the pipette to lower the volume of liquid down to the meniscus here, but you've got much finer control with your fingers. So equally, if you just draw up to about here, you can put your finger on, swap your finger over as need be, and then use the fine control of your finger to lower the solution down. And if you overshoot, well, it's no big loss, no sort of like hazard there. So we just go down slowly. You can't see the angle on the camera until the meniscus is in line with the line on the volumetric pipette, which is there. Take from solution and into the conical flask. While that's running out, we can prepare our indicator. We're going to be using phenolphthalein. This is colourless in acidic solutions and will turn pink in alkali when we've added enough sodium hydroxide to react with the potassium hydrogen phthalate acid. So we add 2 to 3 drops. Here we go, 1, 2, 3. And we're now ready to proceed with our titration. Make sure that the flask is well below the level of the tap so that none of the solution falls outside of the flask. And we need to take an initial reading on the burette. We can do that by looking across here. You may be able to pick that up on the camera. That is 0.7 centimeters cubed. 0.7 centimeters cubed, which we write in our lab book. Now, we've already done the rangefinder titration and we found that we needed 27.5 centimeters cubed of the sodium hydroxide to neutralize the acid. So 27.5 plus 0.7 is 28.2. So we should be able to run down to 27.2, which will be, luckily we've looked at that because it will be obscured by the burette there. So let's just raise the burette slightly. So still in the flask there. So we can run down to 27.2 and we should be within a mil of the end point of the titration. So let's give that a go. So the idea is that by running down to 27.2, we expect to be within 1 centimeter cubed of the end point of the titration, as determined by our first rangefinder titration. So we're coming up to 27.2 now, and it's there. And if we swirl the flask, indeed the colour disappears. And now the point is to add the alkali from the burette dropwise, slowly, and we keep adding until we get that pink colour that persists for at least 30 seconds. So now we are very close. Fine control of the burette tap. Got a drop hanging at the bottom of the burette there, in fact. We want it to fall into solution. There we are. Not quite. Got a bit of a stiff tap there, so I was lucky with that addition. Better. One more drop, and that is worth taking a reading at that point. A very pale pink coloration there, and that is in fact 29.2 that we're reading. And just to be sure, we'll add one more drop from the burette, and we expect to see a deepening of the pink colour. So we're now at the moment 29.2. One more drop there, and we've got a colour close to the original rangefinder. Our reading on the burette is 29.2, it's just a little bit over. 29.2 is our final volume for the titration there, and we need to record that in our lab books.